If I were to look at the foundational breakthroughs in AI over the past decade, Google has been at the forefront of many of those breakthroughs.
Gemini is our largest and most capable model. It means that Gemini can understand the world around us in the way that we do. So not just text, but also code, audio, image, and video.
In the last week, Google released the most powerful generative AI model called as Gemini. So this model has surpassed all the performances of previous generative AI models, and it is giving state-of-the-art performance on image, text, video as well as the audio data. So this model is going to create a lot of noise in the market right now. So what we would do is, in this session, we would go through details of the Gemini AI model, on which dataset it is trained, what kind of infrastructure was used, and we would also get into evaluation metrics with respect to results of this model as compared to GPT-4 model. And at the end, we would also discuss about variants of Gemini model and which one you can choose for your use case. So let's get started. Subscribe to our channel for more content related to Python, data science, machine learning and AI. So this is the architecture of Gemini AI model on a high level. So one of the important thing about the Gemini AI model is it was trained on a multimodal data. So what I mean by that, it can take text data as input, it can take audio data as input, it can take image data as input, it can take video data as input. So all kind of data sets it can take as input. This is different feature as compared to other models. For example, GPT-4, it can take only text data as input. For vision or for image data as input, it has a different model. Then for model like DAL-E, it can take text data as input and generate images. So other generative AI models are not truly multimodal. They can take only one type of data as an input, but that's not the case with Gemini. Gemini model can take various kind of data sets as an input at the same time, and it can process it using a transformer architecture, which is the architecture used in the generative AI model. And at the output, it can generate images as well as text. That is again very different. So it can generate output in the form of images as well as text. So the Gemini AI model, the main function or the main feature which is different from other models is it is a multimodal model. It can take various kind of data types at its input. Now, why there is so much noise regarding Gemini AI? I mean, you can see that after every 1 week there are new generative AI models getting released. But why Gemini was able to create so much noise? Obviously, it was released by Google, and the second thing is it is able to cross the benchmark. So with respect to, for example, MMLU, which is massive multitask language understanding. So this is the benchmark on text data, which is used for understanding various complex reasoning tasks on around 57 subjects like maths, science, law or medical. So with respect to that, there are questions and answers. So in understanding that kind of data, the previous state-of-the-art performance was with respect to GPT-4. So GPT-4 was giving performance of 86.4%, and that was still less than the human expert performance. So the human expert benchmark was at 89.8%. But the Gemini model has completely crossed that benchmark as well. So it is standing at 90% at the moment. So this is the reason why there is so much noise right now with the Gemini model, because it is giving the best performance right now in the market. Now, with respect to the training data infrastructure, so as I mentioned at the beginning, the training data used for training the Gemini model is of various data types. So Google has used web documents, books, as well as codes, including images, audios and videos data for training this Gemini model. So this model has information about almost most of the data available on web. It is able to understand the code as well. It is able to understand your images, videos and audio files as well. So it has become like a really powerful model like humans, right? So we as a humans, we understand text, we understand image, we understand audio, video, everything we can understand as a single person, right? So similarly, Gemini can understand all these kind of data types. This feature was not available in the generative AI models released till now. And it is both multimodal as well as multilingual. So it means that it can understand various kind of languages as well. So it is not restricted to understanding just English. It can understand different types of languages as well. So all these different kind of data sets were used for training Gemini model. And when it comes down to infrastructure, so Google has used its own tensor processing unit. So you might have heard about tensor processing unit. So it is something which is used for faster processing of data. It is like another version of, say, GPU, right? You might have heard about GPU. So Google have used their own tensor processing unit for creating an infrastructure for training Gemini model, because when you want to train a generative AI model on such a large data set, right, you need not just one TPU, you need sets of TPUs. So they have used TPU accelerators which are deployed in the form of super pods of 4096 chips, and they have used these TPUs which are spread across data centers, and all those data centers were used for parallel training of a Gemini AI model. And that's why it has become so powerful, because it got good training infrastructure, huge data, and right architecture as well, because it is able to learn from various data types, which is as good as a human learning behavior. Now, it is very powerful on the complex reasoning ability. So you might have solved some physics or mathematics problem during your school days, right? So if you give similar problem for evaluation to the Gemini model, it would be able to evaluate it as well. So now you see an example over here where there was a solution of a physics problem which was given by a student. So this solution was in the form of image. Okay, so you see some image over here and the solution written below that. Now, if this data is given as input to Gemini model, first thing, from the image, it is able to understand what exactly text is written on that image. So it is able to understand the data really well based on its training. And the second and very important thing is its complex reasoning ability, because it is able to evaluate this answer and it is able to come up with its own answer and suggest a right answer along with step-by-step explanation. So it is able to explain the steps as well. So this is the complex reasoning ability of a Gemini AI model, which again is really powerful, because from the image data it is able to come up with the solution by evaluating the solution written in the image. So you can imagine the kind of applications Gemini AI can create. So you can create maybe automation for evaluating written documents, automation for evaluating written papers, right? All that kind of automation can be created using Gemini AI. So this image to text kind of feature was already there in many models. But this is not just image to text, it is understanding that text along with the complex reasoning ability. This is what sets it apart from other generative AI models. Now, when it comes to evaluation, right, I mean, just seeing few examples as a data scientist, we should never trust the model. Where we should really compare is the kind of evaluation that we are getting. Now, this is the evaluation released by Google in their research paper. So what they have released is for the MMLU benchmark, the Gemini Ultra model, which is their most powerful model, it's sitting at 90.04% accuracy. But the GPT-4 model, when compared on the same data, it is at 87.29%. Now, in this, they have done evaluation using various methodologies. Now, in this case, they have used chain of thought prompting. So what is chain of thought prompting? So chain of thought prompting is a methodology in which you give examples to the model of, say, questions and answers. But when you give answers, you also give the steps involved in coming to that answer. So like we teach any humans, right? If we just tell question and answer, right, it would be very difficult to teach anyone. So we always tell in the steps, right? First you do this, then you do that, and this is how you arrive to the answer. So to the model, if you give questions and answers in this format, where in the answers you are also explaining the steps, that is called as chain of thought prompting. So on the chain of thought prompting benchmark, the MMLU model is doing better. The Gemini AI model is doing better on the MMLU benchmark using the chain of thought prompting. If it was not just based on chain of thought prompting, and if it was based on few shot learning. Now, what is few shot learning? So in few shot learning, you give questions and answers to the model, but in answers you don't tell the steps. You just give questions and answers, and then based on that, model learns. That is called as few shot learning. So in few shot learning, the Gemini AI model is not performing better as compared to the GPT-4 model. So I don't think many people have taken observation of this difference. So when few shot learning is used, the GPT-4 model is still better as compared to the Gemini model. But by using chain of thought prompting, the Gemini model is giving better results as compared to the GPT-4. So this is where the model is standing. So this is currently breaking the human benchmark standard, which is really good because it hasn't happened till now. Now, when we go to image data, okay, on image data as well, the Gemini model is performing really well. So on the MMLU benchmark related to the image data, the results that we are getting for Gemini model are 59.4%, and as compared to it, the image model similar in GPT-4 is giving 56.8% as the results. So if we compare these two numbers, again Gemini model is really doing well. In reading text from the natural images, right? So their Gemini model is standing at 82.3%. But the GPT-4 vision model is standing at 78%. So again, it is able to build a state of the art. So if you see here, right, it is giving really good results, and it is able to beat its own benchmark created by the previous generative AI model of Google, which was at 79.5%. So this Gemini model created by Google is doing well on text data, doing well on image data, and similarly there are similar numbers published on audio as well as the video data where this model is doing really great, and that's where it is becoming like a powerful model. Now another thing is it can also take text and image both as an input at the same time, right? We explained it at the beginning. So here is the example where you are giving image to the model and you are also giving audio. So in the input audio, you are saying what's the first step to make veggie omelette with these ingredients. So it is able to understand your audio, it is able to understand the image as well, and it is saying that crack the eggs into bowl and whisk them. So it is able to tell you next steps that you should take to make omelette. So this is, I mean, as a human we might think this is so simple, right? But to teach it to the model so that it is able to understand the image as well as audio is a very difficult task, because I have worked on various problem statements related to the image, video and text data, and just to solve the individual problem statements using machine learning was a very complex task. So this model is not solving the individual statements, it is able to solve and get various data types and come up with the recommendation at the same time, which is a really powerful thing happening over here. And just by seeing the images, it is also able to tell you next steps, that maybe this omelette is not ready, you have to flip it. So it is able to get deep understanding based on your audio as well as the image data, which again sets it apart from all the previous generative AI model released till now. Now in terms of the versions, so Gemini has released these models mainly in 3 versions. So there is an Ultra version, which is like the most powerful version of the Gemini model, which would be the most complex model that is getting used, and it would give the best results possible within the various variants of the Gemini model. Then you also have a Pro model within Gemini. So this Pro model is performance optimized, so you would get maybe a bit lesser accurate results as compared to the Ultra model, but it has a lower latency and as well as it gives you like the results at a lower cost, because I'm very sure when the Google would start charging for these models, right, the cost for Ultra model based on the API calls will be on a higher side than the Pro model. So Pro is the kind of a balanced model where you can balance accuracy as well as the cost that you're spending on getting results back. And Nano is the version that they have released for the Gemini model, which is targeted for on-device execution of the models. So in Nano, they have basically 2 versions, Nano 1 and Nano 2. So Nano 1 is the smallest model within the Gemini model that you can use. And when you compare performance of these models, right, you can get clarity that on most of the benchmarks, the Ultra model would be the best model in terms of the results that you can get. So Ultra model is the best model on all the benchmarks, but you need to balance your accuracy as well as kind of money you can spend with respect to the API cost, the delay, because the complex model would take more time in processing the results as compared to the simpler models, right? So if you want something to be done on device, right, then you can go for Nano models. So there the results might be on a lower side, but you get something which is able to solve your problem. So this is how Gemini has released 3 different versions which you can use as a generative AI models. So that's it from today's session, guys, with respect to Gemini AI. What we would do in the next video after a week, right? So we would do some hands-on learning using generative AI. So make sure that you don't miss that video. In that video, we would take some PDF documents and we would do hands-on learning with respect to generative AI in terms of how we can understand those documents using the generative AI models. So I will see you in the next video. Bye-bye.